6.6, we are studying arithmetic sequences today. Okay, pretty easy deal. The difficult part is the notation. So note an arithmetic sequence is an ordered list of numbers in which the difference between pair of consecutive terms or numbers in the list is the same. In other words, you're counting by the same number every time. You're adding the same amount every time. Okay, so what I want you to do right now is I want you to complete exploration 1, A, and B. Okay. Okay, let's check our work here. Finish that up. Exploration number 1. There, we got it. Very good. Is this discrete or continuous?
Discrete.
This is discrete. How come it's discrete, not continuous? Gunner? Because what? Why aren't they connected? Why? Okay, we're going in a circular format here. So why is it not continuous? What's that? You don't. Okay, Cassie, why is it not? You can't have half a star. Okay, we don't have half stars, so you can't go in between 1 and 2, or 2 and 3, and 3 and 4, and so on.
You can't have half a gold star?
Correct. Okay. All right. So describe the pattern. What's happening with the y values? Vincent, what's happening there? Good. Y is increasing by 10 every time. All right. Nice. Okay, the next one. What's happening with our circles every time? Getting another ring. Okay. So the number of circles we got there, we graph it. Once again, we can't have half, so it's discrete, and y increases by 1 each time. All right, that's all an arithmetic sequence is. Please note that when we're graphing this, we actually said n. What does n represent? Tell your neighbor, please. All right, wrap up conversation. Quentin, what did you say?
It's the number in the sequence that we're talking about.
Good. It's the number in the sequence. So this is the first figure, second figure, third figure, fourth figure, and fifth figure. It's the number of the item in the sequence. Same thing up here. First, second, third, fourth, and fifth. It's your position. Okay? All right, any questions there? Why don't you turn the page, please? Go on to exploration number 2. Actually, I guess it's exploration number 1 still. It's just the last part of it. Finish that one up.
This is how I learned how to do multiplication.
Back in the day.
They had groups. They talked about groups. How many groups of 2 do you have? They look.
Man.
1 group of 2, 2 groups of 2, 3 groups of 2. How do we learn?
We've got it. Okay. Sergi. Is this discrete or continuous? Discrete, how come? Okay, we can't have half of a, we don't have, like when we're looking at our n-axis here, or x-axis, you can't have halves down here, right? We're not going in between, and I think we said half a star earlier. That wasn't quite right. We're talking about in between 1 and 2. We don't have 1 1/2. We don't have the 1 1/2 pattern. We don't have halfway between the first figure and the second figure. All right. Very good. Any questions there? Everyone rate themselves 1 to 5 right now? All right. So this is where it gets a little more weird, is when we start looking at our notation. So what I want you to do is turn to page 123. Okay, at the top you have some different terms there. You can define those as we go today. But as you go down, this right here, this actually looks not too bad. Core concepts and arithmetic sequence. So when you have a common difference, you're just adding the same amount every time. You've been doing that with linear equations when you think of your y value. That's what we just kind of related there. It's when you get down here that this stuff starts getting really weird. You're like, all right, you start seeing some notation you haven't seen before. And there are a lot of letters. The equation for arithmetic sequence or arithmetic sequence, a sub n is the nth term of the sequence, with the first term being a sub 1. So what you need to note here, Logan, is that a sub 1 stands for what? No, that stands for our first term. That's what the little 1 stands for. Hi. You have to get it from me here in a while. You have to get it from me a little later. Okay, not quite yet. Okay, a sub 1, that's our first term. Okay, what's a sub n stand for? Aaron? A sub n. Okay, let me help you out. A sub n stands for the nth term. So, you guys, a lot of times, they just kind of explain this stuff up ahead. Okay? Sebastian, what does D stand for? The common difference. Okay, it's what you're going up or down by. Okay? So, a sub n, a sub 1, n stands for the nth term. That means whatever term we're looking for. So, all of these different things we've kind of defined up here. Please note that the letter N, when it's next to A, does not mathematically stand for anything. It's just information. And the 1 does not mathematically stand for anything. It's just information. So it'd be like me saying, you're student number 1, you're student number 2, you're student number 3, number 4, number 5, number 6, number 7. So we call you S sub 1, S sub 2, S sub 3, S sub 4, S sub 5, S sub 6, S sub 7. Okay? It has no numeric bearing, no mathematical bearing other than its ordering. It's an ordering item. Yeah? Nth means whatever term we want it to be. So if I said, tell me what term do you want, everyone pick a term. Like a number in the sequence.
42.
Okay, so everyone, the majority of people will pick different numbers. So we say the nth term. If Kai says I want the 42nd, if Bailey says I want the 3rd, if you say you want the 7th, I say I want the 101st, okay, that would be the nth. It's whatever term we're looking for in the sequence. Okay? So you define n by saying I want this specific term. Okay, so we're going to use this formula a lot today, so mark that in your book. Okay? I want you to take a look at page 124 of your student journal. All right? 1 through 6. Off you go. Yeah, Logan. If they're going up by a non-constant rate, then it's not an arithmetic sequence. Okay? All right. Number 7 through 12 here. I want you to take a look at number 7. Okay, you have been given a sequence. All right? That sequence has how many terms in it? Tell your neighbor, please. 4. If I was to make a table on this, I would be able to set up my table as a sub n, or excuse me, I guess if you want to think of it as a sub n here, and this would be n right here. Okay? That would be how our table is set out, which means my x and y axis is no longer called x and y, it is called... Go ahead and label your axes, please.
First lunch is now over. Please head to your fourth period class. First lunch is now over. Please head to your fourth period class. Thank you.
All right. All right, X, what do you think? What's that? What's this? Thank you, X. X, what's this one? All of you named X. Well done. Okay? So, this is a sub n, this is n.
A bit late.
All right, focus up. A sub n is 1. Okay? If a sub n is 3, and a sub n is 5, and a sub n is 7. Jason, what's n right here? That's 1. Okay, Jason, what's in right here? That's not 3.
That's 2.
2. And this is 3. And this is 4. Now, you guys know that it's just telling you what order. So the first term was 1. The second term was 3. The third term was 5. The fourth term was 7. Okay? That's all you're doing there. So when I'm graphing this, and if I'm going up by ones, I have when n is 1, a sub n is 1. When n is 2, a sub n was 3. When n was 3, a sub n was 5. And please note that this is, since we're going up by a constant rate up here and here, what type of graph are we getting?
Linear.
You're getting a linear equation. Now, do you connect the points? No, this is discrete data. It's not continuous because you cannot have half of an n. There's nothing in between. Okay? All right, very good. Any questions there? A lot of bells today. I want you to complete 1 through 12 on that page, please. 1 through 12.
The bell has a question.
So I've now had 4 questions about the fractions. They are just fractions. Don't be scared of them. I don't think anyone dressed up as one as Halloween. Okay? Hey, guys, that stuff's the same right there. What is 15 divided by 2? And you should not have to use a calculator. 7.5. Just change it to a decimal. Okay? All right. Okay? Good questions. One more minute. Give you a snapshot of what they look like there. Kind of get a quick view. All right. Any questions? Moving on. Why don't you guys take a look at the next page, please? We're now on page 125, the top there. 13 through 15. Go ahead and work on it with your groupies. Okay, time's up. Number 13. Number 13, we've got Miss Hinkler there. What do you got for 13? Oh, Hinker. Sorry. Go ahead. Not linears. Very good. All these have to be linear, so no, it's not linear. You don't have a constant rate there. Well done. Tyler, number 14. Yes, how come? Good. It goes up by 10 each time. It has a common difference. Common difference of 10. Okay, and number 15, Mac, what do you got? Yes, how come? Yeah, it looks like it's a straight line, which means it has a common difference. What's common difference? So what's y changing every time? Mac, what's y going by every time? -3. All right, very good. Ladies and gentlemen, any questions?